Okay, let's talk about lines. So for this video lecture, we have two objectives. We want to, one, calculate the slope of lines, including horizontal and vertical lines, and two, interpret the slopes of lines. All right, let's first define what slope is. Slope is a measure of the steepness of a line. Okay, so it is a ratio, and it's a ratio of the rise or the fall over the run. And the reason I put rise or fall in the numerator is I think it makes the most sense to indicate whether to always run in the positive direction, to always run to the right along the x-axis. And to indicate if your slope is negative, that means you're falling. If your slope is positive, that means you're rising. So it's a ratio rise or fall over run, which is the same thing as saying you're going to take the change in the y coordinates and divide it by the change in the x coordinates. Change in can be rewritten with the triangle. Change in y over change in x, a mathematical symbol triangle stands for change in. The change in y means you're doing y2 minus y1. The change in x means you're doing x2 minus x1. And of course, the slope in mathematics is usually indicated by the letter m. Okay, let's do that. So example 1 here, let's find what is the slope of the line containing the points 1, 2, and 5, negative 3. Okay, so I drew a simple coordinate plane. I'm not going to get fancy. Let's say that 1, 2 is approximately here. I know it's in the first quadrant because both the x-coordinate and the y-coordinate are positive. 5, negative 3, okay, a little longer, a little lower. This is just fine, ballpark okay. I'm not really too concerned about perfection, but 5, negative 3 is definitely in the fourth quadrant. Let's connect those two. Okay, what is the slope of that line? Well, you can clearly see, because you read slope from left to right, that the slope is negative. We're going down as we go from left to right. Okay, so let's see here. M is the slope. The slope is the change in y over the change in x. So we're going to do y2 minus y1 over x2 minus x1. And I'm going to choose to have this be 0.2. I'll make this 0.1 and this 0.2. So y2 is a negative 3 minus y1 is 2. x2 therefore is 5 minus x1 is 1. As long as you go in the same direction, subtract from this point to this point both times, or from this point, if you can call this point 2 if you prefer, and this point 1, and then go this direction. It doesn't matter as long as you do the same direction for both the numerator and the denominator. And you can see here the slope is negative 5 over 4. Okay, now let's interpret that to see how it generally is spoken of. Again, I usually leave, if it's a negative slope, then I'll attach that to the numerator, to the y action or the y movement, and I'll say this line falls 5 or decreases 5 for every increase of 4 units. So, some different ways to interpret it. Okay, how about for every, whoops, difficulty spelling at the moment, or maybe writing. For every 4 unit, notice that's positive. We're doing 4 units, so it's a positive 4 unit. Change in x. The change in y is negative 5 units. Okay, so I keep the x always positive, and associate the negative sign or the positive sign with the y, with the numerator, with the y change. Another way to write this, okay, if x increases by 4 units, again, x going in the positive direction, y decreases by 5 units. Notice I'm using the 5 here because I said decreases by 5 units, which indicates it drops. Okay? Okay, so what you're looking to do, in general, as I've said, I'll write it down. Move positive in the x direction. Move right. In the x direction. When you interpret this and you speak about it, you interpret it always moving positive or right in the x direction, and then you either rise, which is positive, which is obviously positive y, or you increase, or fall. That's your negative y, your decrease in the y direction. That's your interpretation. Okay, now remember, slope is always a fraction. We want to keep that in mind as well. We'll see that come up in future video lectures. It's always a fraction, it's always a ratio. Looking up here again. Rise or fall over run. Okay, let's take a look now at the slope of horizontal and vertical lines. My paper straightened out. What is the slope of a horizontal line? Well, let's draw a horizontal line on the coordinate graph. And I'm going to keep this simple. Okay, so this is my x and my y axis. So here is the horizontal line. Okay. And I'm going to label 2 points on that line. I'm going to label this point and this point. Okay, this point has an x-coordinate at x1 and a y-coordinate at y, because the y doesn't change. This coordinate has an x-coordinate at x2, but the y-coordinate is the same, so we'll just call it y. It's the same. These two y's are the same for a horizontal line, the y coordinates. So what is slope? Change in y over change in x. Okay, y2 minus y1 over x2 minus x1. And let's take a look at that. Okay, well, if this is point 2 and this is point 1, this is y2 and this is y1. So it's y minus y. Notice that it did not change in the y direction. There is no change over x2 minus x1, which of course equals 0 over x2 minus x1. And as you know, 0 divided by anything is equal to 0. Is 0. Okay, so you can see there is no rise or fall as you run, so the slope is 0. Okay, so the slope of a horizontal line is 0. Okay, you're walking along a flat piece of pavement, for a sidewalk, for example. You are not increasing or decreasing. The slope is 0. The slope is not changing. It has a slope of 0. Okay, so again, as the x increases, the y does not increase or decrease. That's the interpretation. As x increases, the y neither increases nor decreases. Let's contrast this with the slope of a vertical line. All right, I'm going to draw the XY plane again. I don't need that much, I don't think. Looks like my x-axis is a bit crooked. That's all right, it's not terrible. Okay, and here is a vertical line. Okay, now let's take 2 points. This is the point X, and I don't put a 1 or a 2 on it because this is the same. They both have the same X value, so I'll just use X. Okay, and I'll call this one Y1, and I'll call this one Y2. I use Y2 and Y1 because the Y coordinates of these 2 points are different. Okay, but their X coordinates are identical, so I just used the letter X. Okay, the slope is equal to the change in Y over the change in X, which equals Y2 minus Y1 because their difference. Well, this is 0.2 because I use 0.2, I use Y2 first, so this is X minus X. Okay, well, this is all good. Okay, this is equal to Y2 minus Y1 over 0. And we should stop right here and say, wait a second. I can't divide. Dividing by 0 is not allowed in mathematics. There's no such thing. It is undefined. So this should tell me something's up. This is undefined. Dividing by 0 is undefined. Okay, so this tells me the slope of a vertical line is undefined. We don't know what it is. We don't have a definition for it. So in other words, I don't, as X doesn't change, there's no way to come up with how Y rises or falls because X isn't changing. So I can't come up with a slope here, so it's totally undefined. So again, slope of a horizontal line is 0. Slope of a vertical line is undefined. Okay, and a brief recap of slope. Okay, it's a ratio, it's a fraction, it's always a fraction. Change in Y over change in X.